Hello, colleagues. This project started as an extension of a previous script I had already built, which generated signals based on token data. I talked about that in another video, where I showed how the script worked. But this time, I wanted to take it further, automating the process, integrating real-time data streaming, and making everything visible in OBS. To showcase everything in action, I launched a live stream on Twitch, where the system continuously processed and displayed signals in real time. Over the course of several hours, 2 new users subscribed to the channel, which was an encouraging sign. I plan to monitor how engaging this type of content is for viewers and see if it attracts more interest over time. If the response is positive, I might expand the project further. The link to the Twitch stream is in the comments if you want to check it out. Step 1. Automating Brave with remote debugging. The first challenge was launching Brave with remote debugging port equals 9222, so I could automate tab management. I set up a .bat file to ensure Brave always started with debugging enabled. One issue I encountered was that newly opened tabs would steal focus, which was not ideal. After multiple attempts, I found the right combination of launch parameters and WebSocket API calls that allowed me to open tabs in the background without disrupting other work. Step 2. Setting up a WebSocket Proxy. With Brave automated, I needed a way to receive data from an external WebSocket and forward it to a local socket.io server. At first, there were connection issues. Sometimes the external WebSocket would not respond, and other times OBS would not receive the data correctly. I went through multiple debugging steps, clearing browser cache, adjusting OBS settings, and refining my WebSocket connection logic. Eventually, I got it working. Messages from the external WebSocket were now being relayed to OBS in real time. Step 3. Querying MongoDB for token statistics. Since I already had a script that processed trading signals, I wanted to enhance it with real-time token statistics. The goal was to fetch the top 5 most frequently mentioned token names from the last 10 minutes and stream them dynamically. This introduced new technical challenges. Optimizing MongoDB connections to ensure smooth data retrieval. Correctly grouping and sorting token data to get accurate top 5 results. Handling missing or undefined values, which previously caused server crashes. Once these issues were solved, I scheduled the query to run every minute, keeping the data fresh and up to date. Step 4. Streaming data to OBS. At first, I planned to display the signals through chat messages in Stream Elements, https://streamelements.com. However, I quickly ran into limitations. Stream Elements imposed restrictions on automated messages, and it was not flexible enough for the level of detail I wanted to provide. Because of this, I decided to build a simple web page instead. The server now sends the signal data directly to the web page, which is then displayed inside OBS as a browser source. This method allows more customization, real-time updates, and a better visual presentation compared to chat messages. Step 5. Debugging and AMP optimization. During the process, I ran into several unexpected issues. Brave tabs stealing focus needed a way to open tabs in the background without disrupting other work. Incorrect token counts in MongoDB queries. Early versions of the aggregation pipeline did not correctly count and sort token occurrences. Delayed updates in OBS WebSockets sometimes lagged, requiring optimizations in how data was sent to the client. Stream Elements chat message limitations. Message automation was restricted, making it necessary to switch to a custom web-based display. Ensuring messages are readable in OBS. Initially, text appeared cluttered, so I had to adjust formatting and spacing for better clarity. Preventing duplicate messages in the web interface. Implemented logic to ensure that repeated signals were not displayed excessively. Making sure data updates every minute without overwhelming the system. Added controlled intervals and checks to prevent redundant processing. Each problem required careful debugging, adding validation checks, and optimizing the data pipeline to ensure stability. Final result, a fully automated, real-time data pipeline. This project expanded on my existing trading signal script by adding automation, real-time streaming, and OBS integration. Brave can now open and close tabs automatically in the background. External WebSocket data is received and forwarded to a local server. MongoDB fetches and processes token statistics every minute. OBS dynamically displays real-time token data. To test everything, I launched a live stream on Twitch, where the system ran in real time. The Twitch stream showcased how data flows seamlessly from WebSockets and MongoDB to OBS, making everything visible dynamically. The link to the stream is in the comments. I plan to continue testing the system and tracking engagement to see how valuable these signals are for the audience. If you have ideas for improvements or alternative ways to display the signals, feel free to send your own script scenarios. I will review them and integrate the best ones into my system. What is next? Possibly AI-powered alerts, better visualization, or expanding this system to track more detailed analytics. This was an amazing learning experience, and if you are interested in real-time data automation, you now have a roadmap to build your own system. Do your own research.